So, hello again. This talk is on Boscovich Atomism. In previous talk I dealt with automatism in general. This time I'm going to deal with Boscovich Atomism. And the book I'm going by is this one by Lance Law White, Essay on Automatism. Automatism is the idea that physical reality, the universe, is made from particles. And I'm picking up what it says about Boscovich Atomism. This is the person, it's Lancelot Law White. It says of him here from Wikipedia as a Scottish philosopher, theoretical physicist, historian of science and so forth. So dealing with the main things he says about Boscovich Atomism. He presented several versions of automatism, but the important one I consider to be Boscovich's atomism. So White says Boscovian point centers, that's the idea of Boscovich atomism, and Boscovich was 1758 proposed to substitute having several advantages for automatism. That is, the smallest units are not extended pieces of matter but persisting physical points evidence as centres of interaction. Only the spatial relations of these physical points enter physics, and every pair of such points are in interaction. So that's the basic idea of Boscovich's atomism. And White says it's ideal for many purposes and mathematically convenient. It implies that each point atom, and I think the word point particle is more appropriate now because atom has been used to mean something else, namely the smallest particle of a chemical element. So we should be saying each point particle pervades space, acting everywhere except where it is itself. A valuable emphasis is thus placed on interactions or changes of relative velocity. But this idea has proved too restricted, at least as Boscovich presented it. And my comment here is any idea seems to need development. Basic idea is good as far as I'm concerned. So you've got the basic idea of Boscovich's atomism, and basically that idea needs working on. And I've complained a lot in other videos about moving goalposts, and well, you've just got to accept that some things need development. In the case of Einstein's relativity, things go under development but are not explicitly stated. And that's why I complained about moving goalposts in that context. But hopefully, from the context of Boscovich's atomism, you can see the basic idea and realise it needs development. So White says Boscovich, and that was in around 1758, blended atomic and quantitative methods in a mathematical scheme for a unified theory of physical point centres. Physical point centres are being the point particles. And so he's saying it's a unified theory, and he does not say that of any other theory of atomism in his book. Of course, the element of that unified theory can get complicated. So he had Boscovich's atomism, and White mentions the influences on that, and those influences coming from Leibniz and other people, and other people such as Vico also thought of the similar sort of ideas. So note now, White is pointing out Boscovich's theory is a mathematical atomism, and earlier pointed out was a unified theory. So it's a unified theory of mathematical automatism. And as a side note, Pythagorean belief was about a mathematical universe. So it was providing a unified theory in a way that Pythagoras wanted. White continues, he says, R.J. Boscovich, a Jesuit mathematician, astronomer and physicist, published in his book of Theory of Natural something or other, it was 1758, the general mathematical theory of automatism, based on the ideas of Newton and Leibniz, but transforming them so as to provide a program for atomic physics. So this is the basis of atomic physics. You've got the basic idea of automatism from Boscovich, and then atomic physics as we know it in modern physics came from that. This has used many novel postulates which have since been exploited. First one, there exists one class of fundamental particles, all identical. Second, there are permanent quasi material point centers of action, finite numbers of them constituting finite systems. Third, they obey an oscillatory alternating repulsive and attractive law of interaction. And that so Boscovich has got this idea of attractive and repulsive forces, and that's not really been fully looked into by modern physics. He also says the other things. So White goes on to say, Boscovich's theory made no quantitative predictions, but it exerted a great influence of 19th and 20th century physics, and that's namely through atomic physics. For it represents the ideal mathematical automatism with the minimal assumptions, central to body actions dependent on powers of the distance. And so I dispute that it made no quantitative predictions. Others have developed the maths such as this person here, Augustus Prince, who's worked out a great deal of the mathematics for this and written the paper called An Analytical Form of the Boscovich Curve with Applications. Also, there's Professor Dragoslav, who's explained about how Boscovich's theory led to modern quantum theory. So White carries on. He says Boscovich's point atoms, which I'll point out we should really call point particles, were no arbitrary invention. They appeared as a natural idea to many 18th century minds. So there was other people thinking on the same sort of idea in the 18th century. And so White says it may seem surprising that in the middle of the 18th century, when little direct evidence for automatism was available, a thinker such as Boscovich should devote many years to developing a systematic mathematical theory which could at that time be only speculative. Yet this was a natural expression of the situation in 1700 to 1740. On the one hand, automatism had always been speculation or intellectual exploration from the known large towards the unknown small, and from 1600 onwards it became inevitable that this speculative idea should be married to the principle of quantity, and even Newton, in one sense the least speculative of thinkers, whose primary aim was to describe the phenomenon in necessary and sufficient mathematics, considered it worthwhile showing that Boyle's law could be derived on certain mathematical assumption. Thus Boscovich was impelled to his task by three great agencies: the tradition of automatism, the principle of quantity, and the Newtonian concept of force. So you can see where all this is coming from. And White also notes that Joseph Priestley was also interested in point particles, and so was Michel. So it's also got these people we can note were into the idea of a Boscovich point particle. He's saying point atom there, but I think it's better to call it a point particle. White carries on and he says the 18th century appears in retrospect as a relatively quiet period in the history of atomism, but the background was being prepared for the dramatic advances of the 19th century. On the empirical side, work was done on that word I can't really pronounce properly, stoichiometric relations in chemistry, and on the properties of crystals, and in the mathematical theory Bernoulli and Boscovich formulated methods whose value became fully evident only much later. So this was the theory behind all these advances in physics and chemistry and so forth at the time. White carries on. In 1833 to 1834, Faraday inferred from his electrolytic measurements that chemical equivalents correspond to equivalent quantities of electricity. He was acquainted with the various atomic models in use at the time, and in 1844 expressed a preference for Boscovich point atoms. Once again, I think it's better called it point particles. So Faraday thought it was a good idea. So White then manages to tie this into relativity theory. Boscovich 1758 and Mach 1883 had stressed the relational character of all spatial observations and the consequent relativity of inertial and mechanical properties, but continuity and contact action implied for the classical mind a physical medium throughout space in a particular condition at each point, and in this medium fixed in absolute space was not given up easily. In 1899, Poincaré asserted that absolute motion is in principle indetectable, and in 1904 he formulated his principle of relativity, which extended to electromagnetic phenomena the mechanical relativity of Boscovich and Mach. So Poincaré is the one stating the relativity principle, and this was before Einstein came along in 1905 and gave his theory. So we see a build-up of things, and basically the basis for Einstein's relativity is Boscovich's theory. It's about dealing with Boscovich's atomism. So White carries on and says the following: this radical transformation of physical ideas rested on two primary conceptions: the relational character of space and the universal invariance of c, the velocity of light. And I've gone into a lot of details about the velocity of light in other of my videos, so I don't think it's being interpreted properly when you call it a universal invariant. White then carries on to quantum theory. The discovery of H, which is Planck's constant, was so surprising, and it conflicted so violently with what had been regarded throughout the 19th century as basic physical principles, that it has been regarded by some as a perfect example of pure induction from observation, the facts compelling the scientist's mind to adopt conclusions which could only be reached, and were in fact reached in this manner, as at a superficial level, and in a vague sense this view may be correct, but it is historically and psychologically misleading. So how Boscovich atomism connects to quantum theory is an interesting subject which needs further looking at. And so White carries on, and then he gives the necessary and sufficient theoretical steps leading from the basic conceptions of Greek atomism to those of the 20th century. And so he's pointing out from democracy, you've got the duality of space, and also the idea of the discreteness of matter, and then you've got the hierarchical structure, and then you've got the properties and the forces and the equivalence and so forth, and the point centres, which is coming from Boscovich. And then it ties into things like electron theory and so forth. And then also it carries on then further, and you get into multiplicity and then relativity and then ideal theory. So further links will undoubtedly be added to this great chain of ideas according to White. So White was writing in sort of like mid 20th century, so he's not dealing with how atomism has developed since then. So in my view, the idea of wave-particle duality, which came in the 20th century, was just a further development, as far as I'm concerned, which can be added to the basic idea of point particles coming from Boscovich in the 18th century. Thus we now get to my conclusions. Basically, the complicated issue of atomism and how it is evolved to what is now mainstream physics, which was Syria, early 20th century I'm referring to, when it was taken up by building atom bombs and so forth, and when he developed had Einstein's relativity in quantum physics, and that how that atomism is evolved is ignored, stroke omitted from what is taught to physics students. So it's no wonder modern physics is messed up. People are not being taught the basics. They're not being taught the basics of atomism. So that's the end of this. Thank you. The end.